everything, because that's what. And and so the film and the figuring out how to do that darkroom stuff pulled me into photography, and I just do like landscapes and family pictures and stuff. With another one of our work colleagues, I did do 3 or 4 years of evening courses at George Brown College. I don't know whether that made me a better photographer or worse. We'll see. Anyway, let's get on with it. So tonight, what I want to talk about, there's a warning that I want to make sure we talk about first. And that comes from our electricity factory, where, of course, we focus safety, safety, safety. I'll talk a little bit about what an eclipse is, and more importantly, what we're going to see in the eclipse, because most of the time we're not able to see the things that an eclipse reveals. So there'll be a little bit of astronomy at the beginning. And when we talk about that, we have to talk a little bit about the sun and the moon. We'll talk about where to go. And the teaser so far is don't stay at home, right? You will miss it. 99.7% eclipse in Toronto is absolutely no, never mind. So don't even think about staying home. And of course, we'll talk a little bit about how to, and I'll use a lot of my own experiences to help describe that. So moving on, the first thing is the warning. And this actually comes with a little bit of experience, thank goodness, not my own. When I was a little younger, not quite interested in astronomy yet, I think it was 1970, there was a solar eclipse, and we were told in school, don't look at it, don't go outside, it's bad, it'll hurt you. And one of my school friends, Sarah, decided that she actually wanted to look, and she heard about the hurting part. And so she thought, well, I'll just cover one eye and I'll watch it and it'll be okay. And if my other eye hurts, well, then I'll still have a good eye until the other one's better. And of course, today, Sarah is blind in that eye, and it'll happen within a few seconds. So unless the sun is like on the horizon or behind a solar filter or behind the moon, don't look at it. And by the way, I also learned the hard way that if you accidentally leave the cover off your telescope, it'll burn a hole right through your shutter in an instant. So don't do that either. I wonder what happened there. Is the screen still showing for you?
Yeah. Yes.
Okay.
Yes.
I think
looking good.
Surge, but fortunately for us, everything's on a universal backup, so it's all coming back. So I'm going to talk a little bit about how to photograph and enjoy the solar eclipse. This is my wife, Sue, enjoying the solar eclipse. She's not an astronomer. And there is the telescope that I will use again this time. It's basically it's a 500 millimeter telephoto lens. I thought I'd introduce a few things like high level first, and basically what happens during totality. I mean, it's gonna get dark. It's gonna be dusk dark, and when that happens, the day is gonna cool down, sometimes as much as 10 degrees centigrade. You notice the birds stop singing, the animals all go quiet. When you look all around you for 360 degrees, there will be a sunset or sunrise. I don't know which one is it. The corona absolutely bursts into view at that moment that the bright solar disk is hidden by the moon. We'll see stars and planets will come out. Probably see Venus and Jupiter even before totality. Everybody around you is going to get all excited, and hopefully that's even contagious and everything. So continuing on here, some of the high level things are you got to be in the right place at the right time, and that involves knowing where the totality is going to be and knowing where your weather prospects are best. So I've got some suggestions for both of those. I've talked a little bit about what to expect, and we'll go into much more detail to help you choose what it is you want to focus on with photography. So knowing what you want. Reminder to practice, practice, practice. You've all probably used your intervalometer inside your camera at one point in time. Can you do it without thinking in 30 seconds or less when the moon shadow is coming? I don't know. I'd be practicing. I know I'm going to. And then probably one of the most important things is to make sure you just stop. Many astronomers advise that the very first time you see an eclipse, you just watch it. Don't even take a camera. Well, that's kind of not up our alley at all, is it? So last time I devoted half of the time to just looking and the other half to photography. And I prepared and was ready and practiced, and I got some reasonable shots. Did I get the best ones? Probably not. But I think you too can do the same with some advanced practice, with some advanced knowledge. But whatever you do, stop and enjoy. I will say one thing about my non-astronomer wife there. We totality happened, and I chose to look first. So the first minute we were both standing together, soaking it up. And then I went to the telescope and the cameras and was totally focused on that until the end of the eclipse. And as soon as the sun started to come out again, back on went the solar filter. And I turned to Sue and I saw tears coming down her cheek. And I thought, oh, did I step on you? Did I bump into you? Did you bang into something in the dark? I said, what's up? Are you all right? And she said, I never thought it would be so beautiful. So make sure you stop and look. Solar eclipse, as some of you have alluded to, you got to be in totality. And that's that blue line down the center there. And you can see various cities that are listed. Toronto, not one of them. And some have said, oh, I'll go to Hamilton. It's just inside. Well, you see, Hamilton's actually got nearly 2 minutes of totality. Right on the very edge, there's almost no totality. But as you move in, it gets more quite quickly. Coburg, I think, has a minute. Niagara Falls is 3 minutes. Richard, you'll be fine. In St. Catharines, I think it's more than 3 minutes. But the real message of this slide, is to be underneath that blue shadow. It's absolutely no never mind without it. So on to a little bit of science. What is an eclipse? Well, I mean, the short story is light from one object temporarily blocks another. And it can happen on other planets too. It happens on the moon when there's a lunar eclipse and they look back at, the people who live on the moon, they look back at Earth. They get solar eclipses. This picture that you see is actually an eclipse, but it's one where the object is much, much smaller than the sun. It's the planet Venus, and that's what that black dot is there. Sometimes we see sunspots. This picture has some sunspots, but that black dot is the planet Venus, and it's more often called a transit when the object is much, much smaller, but it really is an eclipse. And for us, the moon's going to block out all of the bright part of the sun, and fortunately, not the dim part. And this basically is what happens, right? Is that the sun being much, much bigger than the moon creates a shadow, and parts of the Earth, there's no eclipse at all. Parts of it, there's a partial eclipse, but you can still see that intensely bright photosphere is what it's called, the solar disk that we can normally see. And in photographers' terms, it's at least 15 stops, if not closer to 20 stops, brighter than the next brightest thing on the sun that we're looking for, which is the chromosphere. So just outside is not worth it. And then you get this very small 100 kilometers or so wide path that, with the motion of the Earth, the rotation, the revolution, the revolution of the moon around the Earth, that shadow moves quite quickly across continents. I think it's going to be 20 or 30 minutes to go from Mexico to Newfoundland. It doesn't take long. That's why we have to be ready. Couple of different kind of eclipses we see on Earth here. We see solar ones and we see lunar ones. Most of the eclipses that I've seen anyway, and then most that are easy to see, are these partial eclipses. Once you've seen a few, they're kind of similar, but they are still all interesting. Some are really interesting. A couple of years back, we had one that right here in July, and the sun was rising eclipsed. And I found a place just north of my house, and with use of an iPhone app, I was able to tell exactly where the sun was going to rise. So I put it in that little V-shaped valley, and wish I'd say that I planned for the clouds. I didn't, but they sure made it kind of neat. So sometimes the partial eclipses are neat, but They don't hold a candle to the. Another kind is an annular eclipse, and this is when the moon is a little further away from us than an average moon, and it doesn't quite cover the sun, and it's really just a special case of the partial eclipse because anytime you can still see that bright photosphere, which is the orangish colored part of the sun there that is filtered, you can't see anything else.
So Ian,
yes, sir.
I think we have some noise in the background. I'll just encourage everyone to put their microphones on mute.
Ah, excellent. Okay, yeah, because it's pretty quiet back here.
Okay, I think we're good now. I don't hear it now. Good.
Excellent. Okay, so then of course there's the total eclipse, which is what we're going to talk about here tonight. And there is something that happened recently called a hybrid eclipse, and that's where the moon was getting closer and closer and closer to the Earth while the eclipse was in progress. So it started out as an annular eclipse and it went into a total. They're very rare. But I tell you, I wouldn't wait in the annular part. I'd be going for the total part. And then lunar eclipses also have partial phases. Some of them are umbral, which is the dark shadow, which if you're the person on the moon looking back at the Earth, you get a total eclipse. And then this is the partial eclipse phase. We're actually going to get a penumbral, which is the really partial kind of eclipse. We're going to get one of those on March 25th. It's going to start at 1 a.m. It's going to finish at 5:30 a.m. But it's only this faint part of the shadow. And as an astronomer, I will be staying in bed, so you can suit yourself. And then we get the total eclipse of the moon as well. And that one's kind of neat in that it goes very dark and then goes this beautiful red color. And that red is the all of the sunsets from around the world, in the fact that the sun is still coming through our atmosphere and it gets bent and refracted. But as we know with the blue sky, the atmosphere also scatters the light, and it scatters short wavelengths first. So when the sunlight impinges on the atmosphere, it scatters the blue first. That's why the sky is blue. And when there's a lot of atmosphere to go through, like at sunset or sunrise, it scatters all the other colors except the red. And same with this lunar eclipse, is only the red light left to fall down on the moon, and that's why it's red. And you probably noticed, I'll go back that one slide, is that the total lunar eclipse is a full moon, and the total solar eclipse, you can't see any lit part of the moon at all. It happens only at new moon, and this is of course why. And I won't. Oh, wait a minute, it's not going to go. Wonder why it's not going to go. That's funny. It worked earlier too. Oh, there we go. So this is a nice little animation showing the rotating Earth, which is also revolving around the sun, the revolving moon, which is rotating around the Earth, and the view from what we can see. The bright side, this side is, of course, the side where the sun is. And you can see that only during a new moon, which is as the picture shows right now, can you get a total solar eclipse, and only during a full moon around the back. And before this animation stops, is the moon rotating like the Earth, or is it not? That's the question, and answers at the end, okay? Tell me what you think.
Okay, at the end we'll answer that.
Yeah. And one might ask then, if the moon's going through full moon and new moon once every 29 and a half days, how come we don't get a nice eclipse every 29 and a half days? Why are they rare? And the answer is that the moon's orbit is inclined a little bit to the plane in which the Earth orbits the sun. It's like we're both on the same dinner plate, if you will. But the moon's tipped a little bit. So every now and then it happens that it falls in our shadow. But most of the time when it goes through new moon or full moon, either the Earth misses the moon's shadow or the moon misses the Earth's shadow. So that's why it doesn't happen very often.
Hello.
Hello.
Pretty good.
Anyway, I'll keep going.
Yes, she is.
Whoever's
Okay, then.
You could mute your
You're
microphone.
welcome. Bye.
Thanks, Don.
So I thought I'd share my favorite moon picture before we stop talking about the moon, or almost finished talking about it. This one comes from my daughter when she was 13, and it was before. Well, I guess digital cameras had started, but they were expensive. And it was certainly well before smartphones, because every time I put a telescope out in front of a member of the public, they slapped their smartphone on the eyepiece to get a picture. And I've been trying to get a good picture of the moon for a heck of a long time. And we're at a star party, which is nothing what you think with party-wise. If it's a clear sky, it's absolutely nothing what you think. If it's a cloudy sky, it's absolutely everything what you might think. Anyway, I'm setting up my telescope, and Emily says to me, "Dad, I want to take a picture of the moon." And I thought, yeah, okay, I've tried for 20 years. I haven't got a good one. Go ahead, kid. Go ahead. Make my day. And so off she goes with a smaller telescope of mine and her mom's point and shoot camera. And the first image she tries to take, there's a big flash of light over at the telescope. Emily, turn the flash off. And I thought to myself, she'll never figure that out. Well, of course, she figured it out in 2 seconds. And the flash was off. And then she came trotting back about 10 seconds later with this picture and says, "How's that, Dad?" Oh, that's a pretty darn good picture, as a rotten kid. It's even better than it actually looks, because I don't know if you can notice this little X that happens to be right on the terminator, which is that day and night transition. That's the lunar X. And it's a couple of mountaintops that in 1 hour out of 29 and a half days, the sunlight just happens to shine properly on the top of those mountains to make an X. And she caught the lunar X as well as a good picture. So anyway, a little bit about the moon. You can see that it gets a little closer sometimes and a little further. You've all probably heard about the supermoon. That happens when the moon is a little closer, and we don't give a special name to when it's farthest away. And this is, of course, where long eclipse totality comes from, and also where annular eclipses come from. When the moon is closer to apogee, it can't quite cover the same amount of the sun as close in, and that's that. So the final question, I guess, with the moon and the sun is, moon's 3,500 kilometers in diameter and the sun's 1.4 million. So how is it that the moon covers the sun? And the answer is 400. It's too bad it's not 42, like Douglas Adams' Secret of the Universe, right? But it's 400, meaning the moon is 400 times closer to us than the sun, and the sun is 400 times larger diameter than the moon. And that's total fluke, but kind of good for us right now, in that means the two are apparently the very same size in the sky, which is about half a degree, actually. And that's about it. And half a degree is about half the diameter of your baby fingernail if you hold it out at arm's length. Different arms and different size fingers tend to work it all out, in that it's about half a degree when you're there. Try it next time on the moon, not the sun. A little bit about the sun now. It is indeed our closest star. Another thing to think about that I won't talk about tonight, but it does provide almost all of our energy. Not all of it. Not the energy that Richard and I played with for 30 or 40 years, actually. It is center of our solar system, not the center of the universe. Everybody knows that's Toronto. And it's about 150 million kilometers away. And that very quickly, with astronomy anyway, becomes difficult with that. Like, what's 150 million? I'm not sure I can even count a million. Well, you can actually, if you go 1, 2, 3, 1 a second, it'll be about 11 and a half days and you'll get to a million. But if you get in the car and drive to the sun, if I drive to Richard's house, it's half an hour. If I drive to my daughter's house, it's 4 hours. If I drive to the sun, it's 170 years. So it's a long way. Mostly hydrogen. It's fusing into helium and right in the core. And it's been doing that for about 5 billion years. Thank goodness it'll go on for a little while longer. It's not going to burn out on us, because some stars do burn out fairly quickly. And it's not on fire. As I said, it's nuclear fusion. This is another eclipse picture, also known as transit picture. This is Mercury, that little sharp, dark dot there transiting the sun. Mercury transits happen a lot more often than Venus transits. The next Venus transit is in 2130 something or 2160. Anyway, we'll all miss it, I'm afraid. but Mercury's every 10 years or so. So you might get another Mercury one. So there's 2 or 3 eclipses already. And then the stars in general, sun being a star, being a big ball of hydrogen. I thought I'd mention something about stars that a lot of people wonder about. And it's only a balance between gravity holding it together and the energy of the fusion trying to blow it apart. So the amount of mass that's in the star governs absolutely everything about that star. It's all of it. It's indeed even from whether it'll be a star or not. Jupiter, another 10 times more hydrogen, would have been a star instead of a planet. The amount of gas that governs how long it's going to live, and it's actually reverse of what you think. Big stars are like rock stars. They live hard, they live bright, they die young, like really young, a few 100 million years. The very smallest burning stars have likely been going since the beginning of our universe, 13.8 billion years, and will go on well after the sun is fizzled out. So, and that's just governed by the amount of hydrogen they start out with, the color, in other words, how intensely they burn, and the temperature, and indeed the end fate. Sun's going to fizzle out. Betelgeuse, that great big star in Orion, is going to blow up in a great supernova one day. Gosh, I hope I get to see that. And then this is just for scale to show you great big huge sun, tiny wee little Earth. That's probably a good thing because otherwise it would all have used up by now and we'd be in trouble. And another thing about the scale of the universe and speed, before we start talking more about the sun and what we're going to see in an eclipse, is that scale. And I'd say the sun's 8 minutes, 20 seconds away. And that's light speed, of course, at 300,000 kilometers a second, 5 times around the Earth every second. So if turn to the person sitting next to you, they are 1/300 millionth of a second away. They're so in the past. Moon's about 1 1/3 seconds. Sun 8 minutes, 20 seconds, I said. The next nearest star, that Alpha Centauri from the previous slide, 4.4 light years, meaning the light's been coming for 4.4 years and it just got to us. Betelgeuse that I talked about, 650 light years. Center of our galaxy, 28,000 light years. Edge of the universe, 13.8 billion. So it's really, really big. We're going to deal with stuff 8 minutes and 20 seconds away and less. So what kind of things do we see when we look at the sun? Well, no eclipse. We actually only see that bright part of the sun with our eyes that can only see stuff in the visual spectrum, the red up to violet. Sun does emit in all kinds of wavelengths. Just about every kind of electromagnetic radiation there is comes out of the sun. We see the bright photosphere, and that's captured here. And I'm using, again, right at sunset, the atmosphere as my filter. Don't look at it once it gets up even a couple more minutes. It's too much. And so that's that outer layer we're seeing, that photosphere. The sun itself, all the fusion's going on in the core. The energy radiates out through the hydrogen there, and you can imagine at the core, at 15 million degrees centigrade, it's really tightly packed. The pressure is absolutely phenomenal to cause the hydrogen to fuse into helium, and that only happens in the core. And then in this radiation zone, it moves out, and then the heat can move fast enough that with convection that it'll go. And at the very top of the convection of all the boiling hydrogen, very pressurized gas. It's more like a liquid than even closer to a solid down lower. It is the top of the photosphere glowing at about 5,500 degrees centigrade, a nice bright yellow star. And we see it mostly white because of that black body radiation. It's emitting all the colors, and it's most brightly at yellow, but it's also got the greens and the blues and the oranges. So it appears full spectrum white for us, for our human eyes. And that's that. Let me get my mouse back. Sorry about that. So this is the photosphere through a solar filter, as taken a few days ago by our buddy Richard. Can you tell us just a little bit about what settings you used for this one, Richard? This is a good image of the sun, by the way. He was really particular about that focus. It's excellent.
So I purchased the solar filter from the company you'd recommended, Kendrick's.
Yep.
And so I was playing with it, and this is the second time I played with it. And I knew that there were sunspots, and I was hoping, well, maybe I can see sunspots. So I put the solar filter on my 180 to 600 zoom lens, and sure enough, I could see it. Now, granted, this is cropped quite a bit. And I was very pleased. I think the ISO I put at 64. I can't remember the shutter speed, sorry.
That's okay.
But 64 was the ISO, the lowest possible
Okay.
for my camera to get the most detail. And then in Lightroom, I was able to then enhance the clarity and the texture.
Perfect.
And so I
Good.
was very pleased that you can see the sunspots.
Yeah, I was pleased when you sent me that picture too. It's great. Thanks for letting me use it in this show. And
Richard, what aperture did you use?
I think I had it wide open. So at 600, it would be 6.3. Because it's at wide open at 600 millimeters, it's 6.3. So wide open.
okay, we're already halfway through the time. I'm going to keep going here, or
Yeah.
close to. So really up close, you might notice in Richard's picture here, the sun's surface is not smooth. It's all speckled, right? There's the sunspots. There's these magnetic disturbances here, and the edges. It's not smooth. It's not. He's not seeing the flames and stuff. Not that it's on fire. Remember, this is actually our atmosphere boiling, and turbulence is degrading the image. It's the bane of us earthbound astronomers. Looking up really, really close from a specialized solar telescope.
I didn't take this photo, by the way.
No, no, NASA took this one. But they've got a special solar observatory right in the middle of a lake to minimize the turbulence, and they can see this kind of stuff. It's like, imagine boiling water at the top of a pot on the stove, going up, releasing some heat, releasing some steam, falling back down again. And the sun is doing that all the time. It's always in motion. Really kind of cool. Those sunspots actually have an 11-year cycle. So Richard made the comment, I wonder if there are any spots. Well, if you'd have picked in the 11 years in between, there might not have been any spots. And indeed, I've seen quite a number of times no spots at all in the sun. And then other times, boatloads. And we're actually in a time where there's quite a few spots, which is a good thing, because in the partial phases, probably the best reason to have a filter going is that focus on those sunspots, and we'll give you the sharpest focus possible. And you'll need a filter to focus on the sunspots. If not, you'll just have to use the edge of the sun at the last second, I'm afraid. I'm going to move on because we're going to rush out. So now the photosphere gets hidden by the moon, and now we're going to talk about the stuff that we can see, stuff that's much dimmer than the photosphere. The first part is this chromosphere. As the name hints, it's about color. This is the chromosphere here on the edge shot. This is the shot I took right like within seconds of the end of the eclipse. So the moon is moving down and to the left in this image, and the sun. So the sun's surface is ever so slightly gonna peek out, and a few seconds after this, it was all over. And you can see that very, very thin pinkish. I think it's actually oversaturated because it's not supposed to be quite that pink. It's a deep red, like what's in like the color of the next picture I'll show. So it's tough to get that. And even there, you can see that the corona is way underexposed now. You're dealing with lots of different brightness levels so if you want to take a picture of that chromosphere, you'll have to go quicker, and then slower exposure with the corona. But it's really neat with even just some modest processing. You can see how the magnetic sun is pulling the lines of this highly ionized gas that it's shooting off, and it's really neat how at first I thought, oh, are these like blobs? Are they parts of my sensor that's no good? Well, no, it's actually the sun dragging that part of its atmosphere back in again. Really, really cool. So that's the chromosphere, the very bright part. And this is another picture of it with a different telescope. This is just an iPhone picture down through the eyepiece. of my solar scope. It's a scope that I can use that only looks at the light of hydrogen alpha. So it's throwing out all the rest of that visible spectrum, and only the red hydrogen alpha light that dominates the chromosphere and dominates the prominences. And that's why even without an eclipse, you can see those things with this specialized telescope. But remember here, I'm also seeing stuff of the photosphere as well. That just happens to be that light. It's a much different effect with the solar eclipse. Can't see the corona. Can't really see the difference between the chromosphere here either. Moving a little further out to the corona, that's the beautiful thing that just pops into view. For some strange reason, the corona gets incredibly hot. I mean, the surface is about 5,500 degrees centigrade, and it starts to get warmer and warmer as it gets out. And then it gets into literally millions of degrees when it gets off into the corona. And that's a mystery of science. We don't know what causes that yet. So who knows? Who knows why? And then poof, out comes the corona. And that's just absolutely magical. And it's like somebody turns a switch on. It's just ding, it's right there. It's also the start of the solar wind, which blows away, which is basically the corona and the rest of the sun's material blowing away. I say part of the sun's weight loss regimen loses about 5 tons a second. 1 ton to solar wind, these ionized particles getting blown out somewhere between 300 and 500 kilometers a second, taking 3 days to reach the Earth, and it loses about 4 million tons a second to nuclear fusion. So it's actually losing a lot of weight. It hasn't lost much since it started. I think well less than 1%. But that's that. So what happens to that solar wind? Of course, it blows out to the Earth. And as I said, these are ionized particles. They get attracted by magnets. Both the sun's magnetism to shape the corona and the Earth's magnetism drags it in to the aurora borealis. And this is a picture of it's actually going to be a stop motion video, one shot every 30 seconds for 120 minutes. And you can see well, maybe we can't see it. Why isn't it going to go? It's not going to go. Sorry, guys. That was a video. Didn't work this time. And then other times it gets really spectacular. This is a friend of mine that I met at the George Brown Astronomy Club, and she's out in Calgary, and Joanne took this fabulous image of the aurora over Calgary. I thought it was just beautiful. So if you want really good aurora, go to Calgary. Even better, go to Yellowknife. Even better, go to Reykjavik. So on to the eclipse. Safety again. This is Sue wearing her safety glasses, her solar safety glasses. As of this morning, you can still get them on Amazon. They're really, really cheap. I would say go and order a bunch of them. If you haven't got them already, go get them. They're really, really valuable. Don't forget your sunscreen as well, because it's going to be a sunny, sunny day. Some of the things to take, and I'll go through this list fairly quickly because it's not as much about. Oh, there's the screen's gone off again on me. So it's not quite as much about photography, but things that to think about. Take that comfy chair, because totality is 3 minutes. Lead up and lead out is an hour and a half, or over an hour anyway. And then remember at the end, everybody's going to want to go home at the same time. At the beginning of the eclipse, people will arrive over the course of several hours at wherever you choose to set up. When it's ended, everybody wants out at once. I plan to just stay where I am. I'm going to be in a campground down in Texas, and I'm staying put. So bring your comfy chair. Get those eclipse glasses. Think about cameras, and I'll talk what's coming up about different kinds of cameras. You know, the narrow view, the wide view. Do you want a video camera? You might even just want to put your iPhone up for a video camera to take that third person look. The mount, you saw the size of the tripod that I had. I would get the biggest, heaviest, strongest tripod you can get your hands on. If you can do an equatorial drive, great. If not, practice on the motion of the moon a couple of, for a few nights earlier with your lens on a tripod, because it does move quickly, and I'll show you that shortly. Again, back to, actually, sorry, I zipped on a little fast there. Filters, Richard's email. Don't forget some coffee, some food, things like that. Bring something you might think that might look good in a picture. Bring a white ground sheet. I'll talk about that towards the end, and a colander, like a strainer. Bring your kitchen strainer. And then those solar filters. Again, as of this morning, Jim Kendrick says every one that he's got is still in stock. He does not expect that to stay. However, expects to sell out. So, and further down on this particular web page, there's a PDF for you to choose the correct filter for you. So there we go. More of the planning. That total phase comes and goes really fast. Think about the fact that you might have to chase those clear skies. As Richard said, he might go to Kingston. He might go to Niagara Falls. I think maybe what's that point sticks out in Lake Erie? Is it Long
Point? Peely
Yeah.
Point.
That might be a really great spot. However, you're going to get stuck there because you and your 10,000 best buddies are going to be all out on Long Point trying to get out at the end. So take that. Lots to capture. So in the upcoming slides, when I talk about what to capture, think about what you might want and take that stuff. Again, with your comfort. And as I said earlier, do you need to practice setting up your interval timer? I think you probably do. And practice doing stuff like I say, like tracking the moon, taking that filter off at the last second without bumping focus. Believe me, I've heard more people when I saw that one eclipse. Oh no, I dropped my lens. Oh no, I dropped, because they're all excited. So practice it. Make sure you don't mess up, because I don't think there's another solar eclipse in North America for probably most of our lifetimes. So what can you do if you don't get a filter? You can use solar projection to watch the progress of the eclipse, at least. And this is how Galileo did it. You don't have a telescope, but you got binoculars. Which is what I was stuck with when I was out in Nova Scotia last year, or 2 years ago. No, it was last year, when there was a very small partial eclipse. I got my binoculars, put them on my tripod, cut the chunk out of the box that the eggs came in. And I only cut one hole, a little bit of duct tape behind the back that you can't see to block out any other light, and focused the binoculars. And when the sun came out, you pointed it out, bingo, you get to see the eclipse. So that's a good way to follow the partial phases of the eclipse if you don't have a filter. As I say, the filter allows you the opportunity to focus in advance. So on where to go. You've already all talked a little bit about that, so I'll go straight to the next slide, which is where I think the best bet is, and why I think this is the best bet is based more on weather than where it actually is. Historically, and of course, history does not predict the future, but the odds are historically, for where the eclipse is in Canada, the clearest skies are down here in the Niagara Peninsula. So that's why if you're staying home, this is probably a good place to go. You might want to think about a day trip in the preceding days or weeks coming up. Find that little gem of a conservation area where you don't think anybody's going to be. Maybe you do choose to go down here. Might be some really, really crisp, clear lines out in the middle of the lake here. I don't know how far out in Long Point you can get. That might be a really good spot. And again, with timing, you can see that if you're just up sort of maybe Clapperson's Corners in Hamilton or whatever, you're only going to get very short part of the eclipse. But Hamilton goes from 1 to 2 minutes, depending even on what part of town you're in. And by the time you're in St. Catharines, it's all but being in Buffalo, except for the fires. At over 3 minutes in St. Catharines. So that's a really good spot to try. I would call that plan A. Pick your plan B with the weather. A way to help pick plan B or even plan A is to use this timeanddate.com website with /eclipse. The screen will come up and you can choose your city. At random, I chose Belleville, and you can see Belleville gets 2 minutes of totality, and it shows you exactly the right times at all of this, where the line is, and you can see it's well off. But yes, Kingston would be better. Brockville would be a little better. Montreal is probably about the same as Belleville. So if you have to go all the way up there for clear skies, well, at least you'll get some. But that's a good site to help you pick what alternate plans might be. The other thing to pick an alternate plan is weather, and this is our astronomers' weather site. So when I'm going to go out observing, I use both Environment Canada website and then Astrospheric. And the reason I like Astrospheric is it doesn't give you so much a forecast. It does tell you how much cloud cover there's going to be, how steady the sky is going to be, and how clear the sky is going to be, with blue being the most steady, fewest clouds, most clear, and white being cloudy. But it also gives you this picture of the cloud cover, and it can be animated if it's live online. I didn't put it live there. But that's a really good website to use, is Astrospheric. It'll help you decide where's it going to get clear at the right time. Astrospheric also has a page on the eclipse, which you may or may not find useful. So the other final thing to consider about your site is as the sky darkens and the moon's shadow approaches or goes away, you can see it. And here in this picture from Glendo, you can see the approaching moon shadow. And this took a few seconds to come, but it's really, really cool to watch the shadow and watch the darkness race across the ground. So if you have the opportunity to see something, say out over Lake Erie, near St. Catharines, let's say, that might be something that would be really cool to see, because it would be very, very, very clear to see that. Or the other side, Lake Ontario, when the eclipse is gone and rushing away from you, same effect, only backwards. So those sight lines are something that's worth considering. Now, what is it you want to capture when you do? I think most of us probably want a narrow field for the eclipse. You might want to think about a wider field for stars and planets. There's the possibility that a comet will be seen. Have that wide field camera around your neck to take that shadow approach too. I actually plan to put my iPhone on a little tripod and just set it on video to take what happens in that 3 or 4 minutes of totality. Might be neat to look back. When you get partial phases, you can do some projection of that and take pictures. You can do it through a lens. People and events around. As I said, maybe you just have a camera going to capture that third person perspective. I don't know, whatever you want. So this is what I'm going to use, and this is what I used in 2017. There's a Nikon D7200 with a crop sensor, not the greatest. And obviously RAW. We all shoot RAW, don't we? And then the native ISO, whatever that happens to be for your camera, and I presume Richard's is 64. The native ISO of this D7200 is 200. So when I put it at 100, in comes the gain filter now to add a 0.5 gain and add noise too, of course. So that's why you stick to that native ISO. Manually focus, turn your autofocus off, manually focus either on that sunspot before totality, and because the filter is in front of the lens, it will not change the focus when you take the filter on and off. So focusing in with a filter on will also means you're in focus. If not, you're going to have to look at the edge of that moon edge in totality, and it's going to cost you a little bit of time. If you're on a tripod, make sure you get a cable release. Maybe use an intervalometer. Although I think this changing your settings might interfere with the intervalometer. This is maybe something better for a standalone camera. Now I've got an equatorial mount here, which compensates for the rotation of the Earth. If you don't have it, go out a few nights before, practice on that moon with your tripod, and know how to gently nudge it along. This lens happens to be a 480 millimeter f6. It's plenty. That's just what it is. I mean, usually for astronomical photos with camera lenses, so with really good ones, you can get away with shooting wide open. Usually lenses need to be a half or one stop down to get to the good part of it. So you might want to consider that, unless you spent like 10 grand on a lens, in which case, man, you use all that glass. I'm not going to bother with stellarium because I've got a slide of stellarium and I'm running out of time already. So playbook, what to do. This is like the day of, right? Get up, check that weather, get your timer app running, which I'll talk about in the next slide. use that partial phase to practice following the sun some more, recheck your focus a few times. Look for those approaching shadows at sunset when it gets close. Take your wide field shots. Something that's kind of important right before totality, in the 1 or 2 minutes before, recheck that focus as best you can, because the cooling day will cool both you and your equipment and the day too. And perhaps I know with telescopes, it can change the focus enough to make a difference between a blurred star and a clear star. So double checking that focus right at the very end is really important. And then finally, just have fun. So Timer, there's an app. It's available at the App Store. And it will time whatever eclipse you set in. It will announce what's coming. Partial phase, here comes totality, 10, 9, 8, all of that stuff. It'll look after everything for you. You can click to hear all the announcements. Most of us probably have an older smartphone kicking around. Well, put it on your home Wi-Fi, download this app, download the it says, Eclipse data, download the specific Eclipse data, and then it can run without its SIM card, and it can sit off to the side telling you all about the eclipse. That's certainly what I intend to do. I've got an old iPhone 5 that's going to work just great for that. And then the eclipse target list, right? So with the filter is all your partial phases, you're approaching totality. And then when the filter off comes, that first full frame image, important to have a quick look at the focus. Bracketing, the astronomers usually talk about as much as 2 EV both ways of what you might think would be a good exposure. I've got some of that coming up. And go longer or shorter for chromosphere and prominences and the corona being the most dim, the chromosphere being the brightest. So here's some pictures as we go along at partial phases. Some people like to put a composite together at the end, so it might be worth your while to write out in advance, like an hour before totality, 45 minutes, 30 minutes, 15 minutes, and make sure you take a partial phase, both going in and coming out, and then you can line up a nice composite. A lot of people like to do that. I've never done it. Doubt I'll do it this time, but it's what floats some people's boat. Right before totality and right after, you can sometimes see, and you can see it up here with the partial phase, and I was specifically looking for that here, mountains on the moon will poke through and poke holes, if you will, in the little edge there. So that's really cool to kind of see that. And then totality comes. This is just, I put my iPhone up, click, and it got really quite a neat picture. I wish the sun was a little closer to the horizon. I could have got some horizon too, and some of that sunset, but it just went great. And then of course, totality. This one is exposed mostly for my for the full extent of the corona. And I mentioned that I had a crop sensor and that nearly 500 millimeters. Well, I'm glad it's not many more, because this is the full frame that came out there. And while a full sensor is going to be a little bigger, it's not going to be a lot bigger. And the sun is quite active magnetically now. The corona could be this size, could be smaller, but it could well be quite a bit bigger. So don't get focal length hungry and get yourself stuck with something that's too long and now you can't get it all in, because it'd be a real shame to crop off the edge.
Ian,
Yes, sir.
can you tell us your focal length for this image then?
Yes, this is 480 millimeter f6, using that fixed focal length, fixed aperture telescope. But
it's on a crop camera.
And this is the cropped camera frame. Yeah, a Nikon crop. So 60%, I think Canons are 50%.
The other way around, I think.
Full frame, it's 40% bigger. What can I say? But in other words, I would hesitate to go more than 500 millimeter focal length, even with a full sensor.
Tip.
You might want to make sure you get a few pictures of just the gorgeous prominences. I took these about mid-eclipse when both the tremendously bright photosphere and the much brighter than the prominences chromosphere is hidden behind the moon. So
Ian,
that's
quick question.
Yep.
You said not to go more than 500 millimeters?
That would be my recommendation. It's Norm that's talking right now, is it?
Yeah,
Yeah, Norm, I got a couple of slides coming up. Do you want to hold these for the techno slide that's coming up?
yep.
Thanks.
I don't think so.
So think about in the middle of the eclipse.
Can you
You're
zoom
going to
out
be
so I
left
can
with
see
just the
the
corona and just the prominences. You might want to adjust your exposure to catch the prominences like I've done here, because they're really quite cool. And remember, this is not a big telescope. This is only 80 millimeter diameter lens. Many of your big telephotos have close, if not more than 80 millimeter diameter lenses. So you're, as you're probably aware, the only the diameter of the lens is the resolution that you can capture on your sensor. And so you don't need a great big huge lens. And another neat thing, this is what you might want to think about the colander for in the partial phase, and not just the kitchen strainer, but you'll notice that all the shadows are partial eclipses. Anything that will act like a pinhole camera will do it. I've seen some really cool pictures of leaves coming out, and then you look at the ground and there's these gorgeous little, like a sea of partial eclipses. So watch for that too. I think down in early April in the Niagara region, there might be some early flowers, early leaves out on shrubs, and we might get some nice opportunities for that. But any pinhole will do. And in a pinch, use a kitchen strainer. The last thing maybe to look for is these shadow bands, which happen. Some eclipses, don't happen others. And this is what the big white sheet is for. Sometime in the 5 minutes to tens of seconds before totality, something in the atmosphere, again, not completely understood scientifically, something in the turbulent atmosphere and the narrowing source of light causes these shadows to wiggle across the surface. Some people don't see them at all. Some people see them stable. Some people see them moving like a curtain opening and closing. Other people say they slither like snakes. Worth looking for. And if you can capture a picture, you've done really well, because not many people get pictures of these. Excuse me. You can see this picture. I had to go back to 2001 to get somebody with a good picture. See if you can get me a better one. So here's some of the techno details that I used. My telescope is at 480 millimeter f6. I would consider anything 300 to 500 ish as okay. Based on the quality of your lens, open it up as much as you can. If it's a super duper lens, stop it down one stop if you only paid a couple thousand for it, because it's just the outer edges are just gonna make it a little more blurry. Remember that astronomical targets are much more sensitive to precise focus and lens aberration issues than it is a landscape or a portrait or something. You really have to have a good, really good lens to do that. So hence if you think you got a great $2,000 lens, try some at full aperture. Remember to take a couple stop down too. Again, I use ISO 200, whatever the native is for yours. Partial phases, a 500th to a 750th, even for the faintest of slivers, because it's like you're spot metering, and when it's very tiny, it's still just as bright as when it's full. With no filter, it's actually not a long way off the partial, a little bit more, but not so much. But the corona, that dimmest part, I found that I needed 1/8 to a 30th. A 15th was pretty good, but make sure you bracket either side. Yes, at an 1/8, you're going to completely blow out any prominences and the chromosphere, but you'll get the fullest extent of the corona. And after all, that's what Photoshop's for, right? To make to make up a few masks and layers to blend in some stuff at the end. You'll find that chromosphere and the prominences can be up to 1,000th of a second to catch just the chromosphere, and prominences maybe 100th of a second at that with the no filter. Play around a bit, but remember to write down what you're going to do, and even write down, okay, I'm going to do 5 shots for a chromosphere, then I'm moving on to something else. Because if you don't do that, all of a sudden it's going to be over and you're going to go, rats, I missed XYZ. So bracket, and have that list going. And I found in review of my images, the ones that were slightly what I thought at the time would be underexposed, I could pull more detail out. And I guess that's, when you look at the histogram afterwards in Photoshop, if it's blown off the top, you're never going to get any detail. If it's a little bit less, yeah, you've sacrificed some dynamic range, but you can pull detail out of it. So I found that I have a bit of a bias for underexposure. This is what I meant about that composite image, in that some people stack it up. Now, over the course of the 2-hour eclipse, the sun moves 15 degrees an hour through the sky. So this is, being half a degree diameter, he's not got this in like the real sky, if you will. It's going to move a heck of a lot more, but it does make kind of an interesting picture. And then finally, this wide field view that I've been talking about. This red box is a full frame sensor on I think it's 24 milli. Yes, it's a 24 millimeter lens. And so this is the amount of sky you're going to catch. And you can see that right in the middle there is our eclipsed sun. Mercury's just up here. Jupiter's really bright. You will also see the brightest stars of constellation of Orion up here and Aldebaran, and you'll see really, really bright Venus. I'm not sure whether we'll see Saturn and Mars. They'll be lower to the horizon. All around you will be 360 degrees sunrise, sunset. And I think the horizon might actually, in a total reverse of the nighttime, where the horizon can be the darkest and while it's still light up above, it's going to be the other way around. That horizon all around you is going to be light. So we may not be able to see Saturn, but if you can, move that down a bit, get Saturn and Mars in too, and maybe your tree or two to give it some scale. So that's really interesting. And then the other thing that's shown in the not shown in the image, but named, is there's this comet 12P Pons Brooks. A couple of nights ago, one of my astro buddies out in Nova Scotia took this picture of Pons Brooks. So it's a real comet now. And it's sporting a tail. The tail might be a few degrees long. Bracket that exposure of the sky here, and you might actually catch the comet as well. And it's say if there's the sun, and you're going to see Venus, the eclipsed sun, Jupiter just tucked in to back towards the sun a bit, and up to the right a bit is going to be that comet. That'll be really cool.
So Ian, in that
Sure.
in that previous the previous slide,
This one?
is that a projection of what the sky would look like on April the 8th?
During totality, that's correct. That is exactly.
Yeah, okay. So that's an April the 8th projection of what
April
what it would look like.
3:20 in the afternoon.
Okay, at 3:20 in the afternoon. Okay, good.
Yeah,
Thanks.
this, because I was talking too much, I didn't show Stellarium, and this is a screen capture from that program Stellarium.
Can you go back in?
Yeah, it's a freeware planetarium program, free to download, and easy to use, easy to learn. You don't know how to do something like add a comet in, Google knows. And you can play around and figure out what comes where, with whatever you want. It's really good. But that's what I did is I made the frame for that size lens, just to show people here's the focal length you're going to need to do that full wide field. So I think your 50 millimeter lens might get Venus and the sun, but I'm not sure it would get the sun and Jupiter and the comet. I might have one at the ready and try. We'll see.
You keep talking about a 1 hour time limit. Unless it's your time limit, I don't think anybody here has a time limit.
Oh, okay.
Oh,
Yeah.
you mean for the presentation? Oh, yeah, no, but
I
just
see.
keep going.
Okay, I'm just about done the slides too. So
Ian, could I bring you back to my question?
yeah,
You said-
when I'm gone, when I'm get to the last slide, what I will do then is I'll pull up Stellarium, because I can show an animation of what's going to happen. And I think the important thing to see in that animation is how fast the sun's going to move out of your 500 millimeter field of view. So I will do that now, because I think the next one is this
so-
is the next.
So Ian,
Yes, sir.
so I think Norm had a question that maybe related to the slide you just showed.
I will go back. Yes, Norm.
You have, on one of your previous slides, you said don't use more than 480 millimeters.
No, I said that's
Why wouldn't you use 600? Because it's going to make the sun bigger in your frame.
yes, it will. But what I'm saying is that the corona may be quite a bit bigger this time than last time, because the sun is more magnetically active. I think the size of the corona could easily exceed the field of view of a 600 millimeter lens.
So if I put a 1.4 teleconverter on a 1 to 400 zoom, that would give me like 140 to 560.
It might. Yep. You might find the teleconverter adds in a little bit too much aberrations. I don't know how good a job the teleconverters do on stars. I know most of my astronomy friends throw their teleconverter away.
Okay, good advice.
Yeah. Sorry about that.
Better know now than later.
Yeah, very true. Very true. So this is something that I have not done, and I'm gonna say this is at your peril. And my advice for this diamond ring is way too fiddly for your first ever eclipse. I think you'll miss it if you try it. Already photography during your first eclipse is a bit of a risk, but hey, we're all photographers. We want to get those images, and I think it's a viable risk. I'm nothing special. I managed to get it, so I think you can too. As for the diamond ring, what it is it's that first 1 or 2 seconds after totality or before totality, where the tiniest little dot of the photosphere is still shining through, and it looks like the name says. It looks like the diamond ring. And some people have got really, really good pictures. Many people have damaged their cameras trying to get it, because this shot gets taken and a few seconds after this, your eye is damaged or your camera's damaged. So I don't have diamond ring images. I'm not going to try it. I'll leave that totally up to you. The last slide was just, again, how to enjoy the things that we've talked about, right? We've talked about how to get in the right place at the right time, both weather, maps, maybe going in advance and scoping out the place you're gonna set up. Know what to expect. Now we know what the what's on that sun's surface, what you're going to look for. You're going to need different exposures for different features of the sun. Know how to use that timing. You may not yet quite know what you want. You may want to digest all this and go, okay, I think I want to stick to wide field, or no, I'm gonna try and get close in. Remind 2 other reminders at the end. Do some practice. Those 4 minutes or 3 minutes of totality are going to absolutely fly by, and you'll thank me later if you practice. And I don't want to have to say I told you so. And again, make sure. Now I've got for at least half. I guess that's really for the people who only have 1 or 2 minutes of totality. 3 minutes, you can probably get away with the first 1 minute, but set your timer and have it go off at 60 seconds. And don't start playing with your camera stuff until that timer goes off in 60 seconds, and then go, because it is so beautiful. It really is. So let me call up Stellarium. And what's come up now, Richard?
So we have Stellarium up on the screen. It shows moon and I guess the crescent of the sun.
Yeah. So this is, and it's paused here. This I've estimated to be about the field of view frame of 500 millimeter telephoto. So now and it's paused right now. So the world has stopped for a moment, and you can see what it is. It's just before totality. And if I start it up, it's going second by second here. Maybe I'll, and you'll notice it seems pretty steady, but look at these stars moving in the background. Remember, this is real time, and this is how fast it's all going to move. So if you're on a tripod, and I think you said you handheld yours, Richard, but I don't think
I
you get
handheld it just because I was
right?
just trying it.
Yeah, an eighth of a second for the
experimenting.
Yeah. So you're going to need to be on a tripod, and you can see how fast this is moving. And let me go one more minute in. There's another minute. Let me try and at my peril moving it back a bit. Oh darn it! Here we go. So it's still going. One more minute. Oh, now it's gone. So my point with this is it's really going to go quickly, and you can see how as totality is approaching, that sliver is getting thinner and thinner. Remember, even at this point, you're not seeing anything except this bright little sliver. Venus is probably out now, Jupiter's probably out, but you can't see anything else. And then all of a sudden it just goes and bingo, it's like that. But again, look at how fast it's moving. We haven't even watched for a minute, and you got 4 minutes worth, and you can see where the moon is. If I zoom out, it might show that totality. Yeah, there we go. And it's still moving quickly. So now we're down to maybe a 50 millimeter lens. Let me go down until we get Venus in. Maybe Venus isn't going to come in. Yeah, there's Venus. So that might be your 50 millimeter lens. So you might be able to get that set up. But remember, if you set it up even half an hour before totality, the sun and the moon are moving 7.5 degrees, and that's probably not a lot. Well, what's the field of view here? 23 degrees. So practice that tracking with your tripod, unless of course you have access to a driven mount like my telescope, and then you're in luck. But if not, sorry. Okay, I think that's about it. Why don't we talk about questions about eclipse stuff, and then I do have a few slides of astrophotography, which we can talk and ask questions about at the same time. So what questions might people have about eclipses from what I've said? What did I miss? What are you still wanting to know?
So I have a question.
Jane, yeah.
Okay, yeah.
It's about the safety part. So you would wear those glasses from Amazon the whole time?
Anytime
then-
you look at the sun. I mean, if you want to get your coffee, bad idea, because they're really, really dark, right? They reject something like 1/100,000. They only let 1/100,000th through. So anytime you're going to look up at the sun at the partial phase, put them on. Absolutely. And they're like $1, right? You might have to buy 20, but still, hand them out
I
to your.
think I remember dark pieces of glass when I was a little kid in elementary school. Anyway, and then the filter on the camera,
Yep.
you have that on and then you remove it at totality. Is that
correct?
okay?
And that's why you definitely need a timer of some sort, whether it's your handwritten one, whether you go and download that solar eclipse timer, the set. Use something, because 5, 4, 3, 2, 1, totality. But much more important, the other end, right? You've only got 1 or 2 seconds of it's over to get that cover back on, because it will do damage very quickly. So and the filters go over the end. Let me go back to the picture of there we go. You can see that in the picture here, there's thumb screws, and these are nylon thumb screws, and they work. It's the same kind of thing. Kendrick doesn't make screw-on filters. He only has these hold-on, these friction fit, if you will. So it's very, very easy to have these, especially if it's not windy. You can have them almost loosened, and it comes off very quickly and very easily. Just goes to the dust cover or the light shield, And but yes, with your eyes, those cardboard glasses, they really are safe. And with the telescope or your camera lens, once totality, you do not need the filter at all. But any of the partial phases, you need the filter.
Okay.
Anything. back to your comment about the glass that we had. Yeah, we used to have welding glasses, or people would even get a piece of glass and hold a candle under it and smoke it to make it dark.
Right? Yes.
Not a good
Don't
idea.
do that. Don't do that.
No, no. Maybe the welder's glass, the darkest of the welder's glasses might be okay, but they will give a really green hue to it all. They drastically change the color of it. The best thing are those cardboard things. You look like a geek when they're on, but you know everybody's got it on.
Yeah. Oh,
So
cool. And just one more. I don't want to dominate the questions, but if I'm in Pickering or if I'm outside of that totality band on the map,
Yep.
does nothing happen or does something happen?
oh, you'll see lots of partial phases.
Okay.
And very close, like Pickering, it will get darker. You probably see Venus, you know, but you see it every night anyway. I shouldn't say every night, many nights. You will see none of the totality, none of
Okay.
it. None of the corona, none of the prominences, none of the chromosphere. You won't have tears running down your cheeks at the end. Well, at least they won't be of joy. So-
That's awesome. You've given us so much information. That this is such a good presentation. Thank you.
Thanks, Gene. My pleasure.
So Ian,
Yes,
I know
sir.
Roy has his hand up, but before I'm going to let Roy talk, I have a follow-up question.
Yep.
So, yeah, you during the totality, you can take off the filter. Now, my camera actually has a screen that comes over the sensor. Is it safe to have your camera pointed at the sun? It's turned off. Will it still hurt the sensor of the camera without the filter, the solar filter on?
It is the dust cover on the end of the lens.
No.
Don't do it, Richard. The
Okay.
lens will focus the sunlight, and just like it burned a hole in the paper as a kid, it will burn right through that cover, right through your shutter, and right through the sensor.
Okay. So
Yeah, very quickly.
So even if you turn off your camera,
Yep.
that's you can
The
risk
light is
damaging
going
your
through the
camera.
lens.
I would.
I think he's saying it'll burn
that
a
in
hole
5
right through that
minutes.
cover.
You need to
Yeah.
get your fire extinguisher out, Richard.
Okay.
Yeah, don't do it.
Or the next day go to the bank and
Well,
get some money for a new camera.
well, I'm afraid so.
Yeah.
I'm afraid so.
Okay. Sorry, Roy, you had a question.
Thank you for doing this, Ian. It
Oh, my
has,
pleasure. Thanks, Roy.
I have been watching this on the calendar for a month, and it's done a really good job of sparking my attention and sparking my interest. And we have a dozen people here tonight doing the same thing. It's fabulous.
Good.
I really appreciate your recommendation of Kendrick. That solar filter, while it's a bit expensive, looks like a really great product. And so I've got one, and I love the fact that it has that focusing, super simple focusing mechanism on it. Makes a big difference.
Yeah, it's good. And I mean, Jim is Canadian. He's a fellow astronomer. He started out by designing electronics for dew heaters, because at night our lenses would get covered in dew, and so he designed these straps that went around the end of the cameras and to gently heat the end of the lens. And one of mine burnt out, and it was right at the end of the warranty. And I walked in and I said, "Hey Jim, I need another one of these." And he, you know, not hey, it broke or whatever. And he looks at it and he turns around and he throws it in the garbage, and he said, I used a part that I wasn't happy with, and he pulls a new one off the shelf and puts it in my hand, like right on the spot. And so he's as honest as the day is long. He's a good guy to buy stuff from. He does good products.
So 2 questions.
And I don't get any money from him.
Yeah, well, I can tell that he's super busy. How do you feel about photo ephemeris?
Ephemeris. So That's the one where you follow the path of the sun through the course of the year? Is that, or no, that's the analemma?
Yeah, photo ephemeris is a photographer's assistant for the azimuth passing of the sun and the moon.
Oh,
And-
okay.
And on April 8th, they've layered on the path of the eclipse.
Okay. I've not used that one. I must admit I'm unfamiliar with that.
Well, I have it open if you want me to show it. I'll only be 30 seconds. I'm not gonna dominate this presentation. So, second question.
It's up to Richard if he wants to let you do that or not.
Well, we'll hear his second question.
Yeah, second question is, you've been so successful in teasing me and seducing me. I'm looking at buying a tracker because more than just the eclipse, maybe I want to use a tracker to do something with the Milky Way, because I think the Milky Way is fabulous. And it could be more fabulous if it was actually tracked for a long duration.
Yeah.
Do you have any experience with Telescope Canada in Georgetown?
I personally do not know. There's is it Ontario Telescope? Is that another one? I don't know them. Privately through Richard, I can send you, don't use these guys unless you want me to say my experience is.
Well, you could turn off the recording, maybe, Richard.
Oh, did you want me to do that, Ian? Turn off the recording and
I wouldn't want to have it recorded, what I'm about to say.
okay, I'm going to turn off the recording. I think I go to
Kind of the end of the session anyway, right?
Yeah, we're gonna-
to- Okay. How about we see if there's any other questions? Then we will do.
Sure, good
then-
idea. Yeah,
And
so
then we'll do it at the very end.
but the tracker, there's a company called Skywatcher that makes something called the Star Adventurer. I have one.
Yes, that's precisely the unit.
They work. They're a little fiddly, but they do work. It's handy to have one of those. They're a little flimsy, but they're the azimuth altitude head that you can put on the top of the star tracker. Makes it easier to acquire a subject. And yeah, they work reasonably well for wider field. I have actually got an image. I'd have to look back and call it up in Photoshop to see what it was. Last year, a fairly nearby galaxy called Messier 101 had a supernova in it. It's off the end of the handle of the Big Dipper. And I didn't have my telescope with me, and I was in Nova Scotia, and I thought, I want a picture of that. So I think I put my 200 to 500 millimeter telephoto about halfway, maybe 300 or 400. And I used the Star Adventurer, and I took, I think, 50 individual frames at 30 seconds each. And I got a picture of a galaxy and a supernova with a Star Adventurer. And while we talk about other stuff, maybe I'll try and find it and bring it up.
That's exactly the system I was looking at, and they claim that they can track an object for up to 6 minutes. Then I guess after 6 minutes you need to reacquire and start again.
So no, what they're meaning there is that particular thing will go dawn to dusk, but the it's not precise enough to stay following the stars. Let me just go forward a little. Actually, the telescope mount that's here, that's a pretty good mount. It's also a Skywatcher one. It's about $2,000. And if I want to take an image of stars longer than 10 or 15 seconds, I use something called an auto guider, which is a separate little telescope which looks at a star, and every time the star moves off the pixel, it sends a signal to the mount. Oh, move back a bit, move forward a bit.
Oh, okay.
So that's why they say 6 minutes, and 6 minutes would be like with a 24 millimeter telephoto lens. 6 minutes would not be a big one, but that doesn't matter so much these days because modern cameras are very low noise, and with freeware programs, what you do is you take lots of short exposures. The galaxy I got was 50 or 54. Yeah, exactly. And the programs automatically stack and throw away the bad ones, and it works really well. So 30, you don't need 6 minutes, and 6 minutes is a pipe dream with anything more than, certainly more than 50 millimeter.
The tracker mount you have there is really for the weight of a telescope, right?
Correct. Yeah. And that one can handle it. Something up to about an 8-inch telescope, not really any bigger. It's a medium size one. I can move on to.
Sorry, folks, took you way down the gear alley here.
This is the main telescope gear. Okay, so that's a bit different. This can handle like 100-pound telescope. Is robotic inside the camera, which is the gray box. Actually, no, the guider is up there, so it's looking at a star all the time. It's constantly correcting. I can get 15-minute long exposures out of this, and I do sometimes. But even with that, if I take one galaxy, I'll maybe over the course of 2 or 3 nights to get enough signal. So I'll be stacking.
Is this particular unit remote, and so you access it indirect, like from Collingwood, you interact from home?
Yep. It's actually in my basement now because I sold this particular observatory. I'm going to put it in Nova Scotia, actually. So where the skies are darker. Maybe not as clear quite as much, but pretty close to it.
Is there another similar rental field in Nova Scotia?
No, it's my backyard.
Oh, okay.
So I'll go back here because we'll talk about these pictures later. Any other questions, Roy?
I
No,
have a
that's
question
like,
for.
sorry,
ahead.
just a comment quickly is I love your comment about practice. One of the other presentations I observed this week made a distinction between practice and rehearsal. Practice is learning the task. Rehearsal is doing it on the clock.
That's a good point.
And I thought that the concept of rehearsal is really good. We only have a 5-minute event, right?
It's really it's so exciting. It'll go by so fast.
I
Yeah.
got a question for Richard.
Yep.
Richard,
Yes.
when you took the picture of the sun with the filter on it,
Yes.
I assume you're using manual focus.
Actually, I did.
Huh?
I thought I would need manual focus, but no, the camera did autofocus,
Okay.
and I wasn't sure it would turn out.
Yeah.
And then I did switch it to manual, and the autofocus worked better.
That's a
Okay.
great question. Is how do you focus on an event like that?
So what I did is I focused on the side of the sun, because the sunspots are very small, and so really maybe would have been able to focus on those, but the side of the sun is where I focused, and sure enough, the camera did capture it, and so that's what I did.
Do you remember the focus mode you used, Richard?
Oh, on single focus.
Single point focus.
Yeah, single point focus. Yeah.
Okay.
That might work on the very, very edge. Most people find manual works better for that part of it, but you know what? Give it a go. If it's not working, flick the switch and do it manually.
Yeah.
Yeah.
And so any other questions for Ian before he moves on to some, I guess, astrophotography?
A little bit. Yeah. I haven't
I have one question. I've been on this timeanddate.com/eclipse, and I can't seem to locate the map that you showed us. When I try to zoom in, it goes out of the place where it shows the line for the eclipse. Just can't seem to bring it up for some reason.
Yeah, I don't know. I mean, I all I did was put Belleville in, put that size of it in the screen and do a screen capture, right? So I don't have other things other than that. Oh, and there's Roy's given us the photoephemeris.com. Okay.
Mhm. Okay. So Don, maybe just keep practicing that, and if you have any trouble, you can maybe let me know, and we will try and figure that out.
Okay, thanks.
Okay. So hearing no other questions, I think the most important thing we heard
Oh, I have one
was
question. I have one
only
question, sorry,
take off.
about the diamond ring. How do you, how is that done?
So I have no personal experience with it. Listening to others, you listen for the timer, the eclipse event timer very carefully, because it happens in that 1 to 2 seconds, either before totality or after totality. You have 2 chances, but it's that final little second or so, and you have to, almost be brave and take your filter off that last 1 or 2 seconds, and be focused, and maybe take a sequence, and you might get it. But it's a heck of a risk for your sensor and for your eyes, and probably more importantly for messing something up that means you don't capture the rest of it. My personal choice is I'm not going to try it, but because I would rather, risk versus benefit for me personally. But it's certainly a beautiful picture, Catherine, and having a go like that would be good. I mean, it looks to me like the exposure is somewhere between like there's a little bit of an exposure to catch some of the corona, but not a lot of it. So I would try first around about the chromosphere exposure time, 100th of a second or so. Maybe it's a 500th. I don't know. I don't have personal experience with it, but it's not.
Any reason why you wouldn't take the diamond ring with the filter on?
Yeah, you wouldn't. I don't think you see it properly. Matter of fact, I'm sure you don't,
Okay.
because I watched with the filter on right up until the totality, and I must admit I pulled my eye away from the camera right at the very, because I was after those mountains at the last seconds before, and once I got those, I stood back, took in the view. But the filter blocks out far too much light. It just winks out in the filter. You don't get that diamond ring at all. I mean, the diamond ring is kind of like a gross overexposure of part of your image, really.
Yes.
Yeah. And when you're watching the eclipse, are you watching it through your camera or on your screen?
Definitely with my eyes. So stop me if I'm telling you something you know already. I mean, we know that our cameras are they 16-bit yet? I know 12 to 14 used to be it, and 16-bit camera means it can, get, what is it, 64,000 different brightness levels in it. Well, your eye has got like millions of brightness levels. So as much as you can, just watch it. Looking at the camera screen, looking through the lens doesn't make any difference. For focusing, I would choose whatever your equipment works best for you with focusing. I never look at the screen to do anything. I'm always looking through the viewfinder. That's just old school me. Sometimes if it's a little inconvenient pointing up in the sky, and the screen on the back of your camera can be tilted, you might want to do some centering with it tilted. If you're trying to pick up focus, I think I'd be looking through the viewfinder. I really do. Does that answer the question?
Yep, that's great. Thank you.
It also reinforces the value of rehearsal.
Yeah, very true, Roy.
Okay, Elizabeth, did you have a question? She's on mute.
Oh, you're on mute, Elizabeth.
I thought I heard her voice earlier.
Yeah, you're on mute, Elizabeth.
And one of the shortcuts while you're on mute is you can hold space down and it will unmute for that period of time. Then let it go.
Oh, really? So before Elizabeth joins us, oh, good, she's on mute now. Elizabeth, did you have any questions?
No, thank you.
Oh, okay. I
I
thought I
did
heard something.
very much. I would like to say thank you to Ian and how much I've enjoyed the presentation.
Oh,
Oh.
you're welcome. Thank you, Elizabeth.
So
I
I
have a
know.
question.
Oh, yeah.
I have just a basic entry level 70 to 300 lens.
Mm-hmm.
I bought an 18 stop solar filter for the last partial eclipse, and I got a good shot. However, my picture is black and white. How do I get it colored as like what I'm seeing?
So yeah, I've got a couple of thoughts with that. If it's all black and white, probably overexposed, and therefore you'll oversaturate the colors and blow them out. Try shorter and shorter exposures. Remember too, the filter's throwing away so much light, it doesn't let the full spectrum through. So Richard's filter has a bit of a yellow in it by the looks of it. Mine usually comes out not very much of a color anyway. You can add a bit in Photoshop, but yeah,
that's what I did.
Oh, is it? Oh, there we go.
I warmed it up in Lightroom.
Yeah, I would say it's like one of the two things. That one, the filter's not letting enough color spectrum through, or two, it's overexposed and the sensors doesn't know what to make of it and just records it as a full spectrum white rather than the individual colors. I know that's what happens to me with deep sky pictures. If I take too much data, I get white blotches because it saturates the sensor. But my astronomy camera is ISO 21000, so it saturates quickly on bright stuff.
Okay, thanks.
Okay, any other questions? So I guess we'll move on then to the optional part.
Sure.
Or unless you wanted to, I can pause the recording to address what you want to talk about. For the, I think you were going to talk about mounts, I think.
Yeah, we were talking specifically about where one might buy them.
So I'm going to pause the recording, and I can start it back up again.
Yeah.
I see the pause. Okay.
Here's the people that gave me permission to use their stuff, or have been I didn't ask NASA, but they say you're allowed to use it so long as you tell them, as long as you say that you can use it. So a few astrophotography parts. So this one, a bit of a Milky Way. This is just 30 seconds wide field, and I illuminated my one of my homemade telescopes in the front with my red light, because all of us astronomers use red lights at night. It doesn't ruin your viewing, your night vision anywhere near as much as what white light. That white light, just like the full spectrum, just destroys your night vision. Red is okay. So anyway, I thought it was neat, and I liked the reflection of the sky in Silent Lake, and you get the shadow the other side. It's amazing how much light was there. The next nearest city was about 100 miles or 100 kilometers away, and it was Peterborough. So there's not very much light pollution at the thing. By the way, is this the right way? Protect the dark sky. And there, see my shirt. And this is just a fairly short exposure. I just thought that was kind of a neat how to get started in astrophotography while putting your existing photo skills to use. I mean, create a scene. It's kind of cool. This was Comet News.
A question, please, Ian. Going back, you said that was a 30-second shot. So,
Well, maybe about that.
so if it was 30 seconds at f what?
I I should have looked at the data on the picture and put it in but I didn't. This I have what I leave on my camera is a 28-70 zoom, and I probably zoomed this out to 28, and it's an f2.8, and it's a good lens, so I probably left it open at f2.8. I would have put ISO 200 to try and keep the noise down. I might have gone up to 400 or 800, but I find that with my older D7200, it can't take high ISO and keep the noise down. And, I think that's a bit of a common issue. That's why most of us don't use super high ISOs unless the camera's designed for it. I mentioned my astronomy camera's ISO about 21,000, but it's electronically cooled to 35 degrees centigrade below ambient temperature to get rid of all the thermal noise. It's all of its electronics are designed to be very low noise. That's what it does, right? But our other cameras aren't that, and so I likely wouldn't have gone huge on the ISO, more on the exposure. So yeah, this is. And I think I just put it on the picnic table. I don't think I even had it on a tripod for this, and I didn't sit down the table at the same time, obviously.
Thank you.
The newer cameras actually can record the reds much better. The sensor in my older one doesn't do a great job on the reds. I mean, up in this part of the Milky Way, there's quite a few beautiful red nebula, and they're not recorded very well. This is one of them here, and it's more white and pinkish than red. So the newer sensors do a much better job. Incidentally, this dark area here is the center of our galaxy, and you might ask, why isn't it beautiful and bright? Well, all this dust is blotting it out for us, so we can't see in visual wavelengths. We can't see the center of our galaxy, but that's where it is. And you too can find it in the summer. Now that you've let me into the astronomy part, this is the constellation of Sagittarius, and it looks like a teapot. Here's the handle, these 4 stars here, and here's the spout, the 3 stars there, and there's where the tea is kept, and you see the lid on it, so you can see the teapot, and the Milky Way is all the steam. And this is up in this kind of a position. In the summertime, you'll see it, and this is due south as well. So that's kind of a neat thing to look at. So moving on, this was probably the best comet I've ever seen, and I even saw Halley's comet. This was really cool. It was Comet Neowise back in 2020, and it was a surprise one that we hadn't expected. And this was taken about 5 a.m. I knew it was coming up, and I didn't know what to expect. And I walked out onto it's taken from the dock at the end of the land at our house in Nova Scotia, and I just saw that handheld. Oh my gosh, it was gorgeous. So of course I ran back in and got my telephoto lens, and this is what it looked like in a telephoto lens. And I tried to track a little bit the comet head and not the stars. So the stars are nudged a bit and the comet head is not. And I think if you look really, really carefully, you see it's actually a composite of several pictures, because I aligned them on the comet head and allowed the stars to stay tracked. But then you can see the glowing gas coming off of the comet, and the tail of the comet is much more dust. You can tell that with the different colors, because this is just reflected sunlight, and this is glowing gas that's been sublimated or gone straight from solid to gas off the surface of the comet by the heating of the sun. So that was really cool. I really like that. When I do deep sky astrophotography, this is the kind of telescope I use. It's for us that started out measuring in imperial, 12.5-inch diameter mirror. So it gathers a lot of light, and telescopes are much more about gathering light than how long the focal length is. You do need a bit of focal length if you're going to take planets and stuff. We actually add lenses in to get longer, much longer focal lengths. So like you take a picture of Mars, you need a focal length of many meters, like 16, 20 meters. But this particular one is as I say, it's a 16-bit camera, so it's got a good dynamic range. Nothing like our eye, but still, it's got a really good dynamic range. It's cooled to get rid of any electronic noise, and the mount is as computer controlled. And if I've got an internet connection, I can run the telescope, and it's easy to, the roof this is a roll-off roof shed, and gosh, for your garage door, you can have remote control openers over the internet. So I can remote control opener the roof of the shed, start the telescope up, do everything without ever having to go to the observatory until a wire gets snagged on something. So this is one of the images through that telescope. This is the Crab Nebula in the constellation of Taurus, the bull. And this one came about, this is a relatively new object. It's only about 1,000 years old. And we know that because Chinese astronomers documented this new star. I think it was the year 1054. And it burst forth, was visible in the daylight for several weeks and in the night sky for a couple of years. And then it fizzled away. And then when we got telescopes that could see, because telescopes only been invented for about 400 years, and good enough to start imaging, we saw this kind of a nebula that's growing. And one of my buddies took a picture of this when he was a kid, and he's now like 60, and he takes another picture, and you can actually see it a little bit bigger in the night sky. So this is a really cool object. It is a supernova remnant. It's when you think of all of the stuff that you and I are made of, it's all in that cloud getting blown out into the interstellar space to get sucked up by new stars and made into planets and made into more us. So everything up to lots of heavier elements, more than iron. The real heavy stuff usually needs neutron star mergers, but can happen to much less degree with supernova. But this is a supernova remnant. In the constellation of Orion, and you will see this to the left of Jupiter in the night sky in our solar eclipse times. Just in that totality, you'll see the constellation, the winter constellation that we're probably quite used to. Orion, he's got his 3 stars across the belt and stars in the shoulder and stars off to one side. But anyway, off to the left-hand side of the belt is this. This is commonly known as the Horsehead Nebula. This is one of the bright stars of the belt. And if you start exposing long time, you get this beautiful glowing hydrogen gas, which is red. This has got some other gases like oxygen and neon in it. So it's a slightly different red color than this one. And then the Horsehead itself is actually just dust, and it's obscuring this background nebula, this background emission nebula. This is taken with a relatively small telescope. It's got a 127 millimeter diameter lens, 5 inches, and focal length of, I think, 660. So that makes it about an f5.2. A great lens for telescope for capturing objects that are fairly large. This is really quite big in the night sky. The full moon would be about this big as the circle I'm making here. So it's actually several full moons wide. It's quite big. And so you need a short focal length lens to do that. In sharp contrast to the next picture, which is the Whirlpool Galaxy. This is taken at my about 2,750 millimeter focal length. This is my main telescope, the 12.5 inch, and the 12.5 inches gives me the resolution to get all the the various detail of the galaxy. This will be probably 40 or 50 separate frames. And that little camera that I showed you off the end of the telescope is monochrome. And it's got light filters in front of it. So what I do is I take most of the image in the highest resolution possible of the camera, not binning any of the pixels. So they're 9 micron square pixels over basically a 35 millimeter frame. And I let it go at full resolution, and I take the full spectrum of colors. That's called a luminance frame. And I'll do probably 20 or so images, 10 to 15 minutes long, and one after another, but gathering up all that data. And then the camera will rotate a red filter in front of the sensor, and I'll take some red frames and some green frames and some blue frames. But I will also bin the pixels. So instead of 9 microns by 9 microns, I'll bin them 2 by 2, meaning they're now 18 by 18, 4 times as sensitive. So it doesn't take as long to gather the color data as the luminance data. And I only need 6 or 7 color frames minimum. Better to get, the more is better almost, but in the computer, I'll stack it up and I'll make a color.
Really valuable for,
I'll make a color image and then stack up and sharpen and do all the processing on the luminance frame, and then do a luminance blend in Photoshop to paint the colors from the color frame onto the very high definition luminance. And this galaxy is really neat. So this is about 25, 30 million light years away. It's one of about 3 trillion galaxies that are up in the night sky. It's maybe about 50 or 60 million light years across. Our Milky Way is about twice that size. So meaning light's taking 50 or 60,000 years to go across it, right? And 25 million years to come to us. The older stars in the center are more yellow. They've burned more of their hydrogen. They're starting to yellow and become even more reddish yellow. The newer stars out in the arms are hot and blue, and you can see the bluish ones. And then the pink dots scattered throughout, those are new emission nebula, something like that Horsehead Nebula, that are right now condensing into new stars and new planets. Sadly, that's too slow for us to see in our lifetime. And you can probably also see that there's another big galaxy getting torn apart by the and then there's lots of little galaxies in the background. This image is processed to show on a computer screen, so I've gotten rid of a lot of noise and stuff. It also gets rid of a lot of dim galaxies. But when I take a frame like this, which is not quite, but almost like the moon fits in this field of view, but only just. I usually get 100 or so background galaxies. Sometimes I get several hundred background galaxies. It's truly remarkable how much stuff is up in the night sky. I think this is the last picture coming up. This is what our sun is going to look like probably in about 5 billion years. So this is it at the end there. As a star ages and consumes its hydrogen to helium, it gets lighter. And remember, I said that it's a balance between gravity making it smaller and all the energy of fusion trying to make it bigger. And so what happens when there's less gravity is that the stars actually swell. It's kind of like us humans. When we get a little older, we get a little bigger around the middle. So the star will actually swell as the mass goes down, which is kind of counterintuitive. And eventually our sun will swell up as big enough to gobble the Earth. I shouldn't say that, because it will swell up to the size where the Earth currently is in orbit. But because the mass is going down, the Earth's going to slowly drift further and further away from the sun. And so the Earth shouldn't be gobbled up by the sun, but Mercury and Venus almost certainly will be. Don't worry about it, though, because all the water will be boiled off in 700 million years. We don't need to worry about it. But what happens at the very end is the star is not able to hold on to its outer atmosphere. So it puffs several shells of gas off over the course of 50, 100,000 years of towards the end of its 10 billion year life. And these blow out into space. And you can see that there's actually a couple of different shells. There's a few different gases. The bluish stuff is more oxygen, and the reddish stuff is hydrogen. And that's gently blowing out into space. and is very similar to what our sun will look like in 5 billion years. This one's called the Dumbbell Nebula. Some people think it looks like one of those little hand barbell dumbbell things that you might lift to pump up your muscles. Other people call it the Apple Core Nebula. I think I like Apple Core better, to tell you the truth. Looks more like an apple core that's not quite finished to me. So that's the astrophotography. I guess one other comment about this image is that all of the stars you see in the picture are within our galaxy. So they are like, if I'm wearing my glasses, they're like the dirt on my glasses, and I'm looking at the tree on the horizon, which could be thought of as the galaxy far, far away. And in between that is intergalactic space, where there's almost nothing at all. So that light left that galaxy 30 million years ago. Where were you 30 million years ago? And that's what it looked like back then. It looks like it's revolving. It is. And so this galaxy probably takes 250,000 years to make a revolution. Think of how many times it's gone around in the intervening time when the light's coming out. Probably doesn't look like this anymore. But anyway, that's a brief taste of astrophotography. Oh, one last one. I like this image because these three galaxies, there's three big ones. This is actually a galaxy. This one and this one, they are at a distance. This one in particular is at a distance where the light left it when the dinosaurs were getting extinct, so 65 million years ago. And I kind of like the contrasting shapes that this particular grouping of galaxies make. So anyway, any astrophotography questions? Because I could go on forever and even bore myself, let alone you.
Oh, it's very good. Any questions for Ian?
Do you have to end up becoming nocturnal to do this kind of stuff?
To learn the night sky and to get your feet wet, because yes, in that part, because as you might imagine, it's a bit of a black hole from an equipment point of view, and it all has a learning curve. But now that I know what I'm doing and I've got a robotic telescope, the sun will set enough, because we need astronomical twilight, not just civil twilight. So, and I will acquire the object, get the guider going. The computer will look after taking the exposures, rotating the filters. I set my alarm for 4 in.the morning and I go to sleep, and I wake up and I'll have a quick peek on the computer and go, yep, everything went good. Close, shut the telescope down, close the roof. I sometimes don't even get out of bed to do that.
But you're getting up at 4 o'clock to do that?
Oh, the alarm goes off. 5 minutes later, I'm asleep again. I'm one of these people that has a, I call it a skill. My wife calls it luck. I can fall asleep anywhere. I've always been able to do that. And like less than a minute, I can be asleep just about anywhere. So that works. But yeah, you do have to be a little bit nocturnal. I do astrophotography and I do my own visual astronomy. I'm rarely out later than 1 a.m. in the morning when I'm doing visual. A few times I've realized the sun's coming up before I'm finished looking at what I want to look at. But most of the time I'm in bed by 1:30. And that's not dramatically later than, 10, 11 o'clock. That's really not a ton later.
Having a robotic telescope, I think, offloads a bunch of that.
It does. And it's got a lot easier to have robotic telescopes now. But it's really worth learning it under the night sky. And
do people rent hours, evenings on scopes?
Yeah, there are telescopes you can do that. The Royal Astronomical Society of Canada Toronto Centre has a telescope down in California that you can rent time on, and do some imaging with that. And that one's kind of unique for somebody who doesn't have all the techno gear and doesn't have the time to get into that, because you can use that telescope. Somebody else has set it all up, and you just tell it how many pictures of this, that, and the other you want, and away it goes. And a day later, the data is emailed to you. And that's probably way cheaper than getting your own stuff. Is it as satisfying? Depends what your end result is, right? I think for all of us, I like the odd picture on the wall, but my favorite part of astrophotography, regular photography, is the doing of it. So, I mean, what I'll often do with the astrophotography is I take two telescopes, and I tease my wife, well, I've got two eyes, I have to have two telescopes. So I get the one going with the camera, and then I'll go out with my visual telescope and enjoy the night sky. It's one of the three things that I do that my mind goes completely blank. I don't think about anything else, and is when I'm out under the stars, the telescope. For some reason, everything else goes away. And there's lots of things you do in life that other things go through your mind, but that's one of the three for me that I've identified where I think of nothing else. The other one is when I got the piano in front of me or the guitar in my hand. The final one is when I'm skiing down a steep slope, but that's probably more self-preservation than anything.
So I remember, Ian, when I first were introduced to astrophotography with you, you were drawing out the stars and the I think they call it the Seven Sisters, the Pleiades, Pleiade. You were drawing it out on a piece of paper.
Yeah.
Yeah.
That's an interesting comment, Richard, because I started astrophotography in I guess I was still going to high school. And it was really hard back then, right? Because we had reciprocity failure with film meant that, your Kodak Tri-X black and white film would be back then ASA 400 for the first like 5 seconds, and then it would drop off in its speed. And so you could do two things to stop that reciprocity failure. You could bake it in a nitrogen gas to drive off all the free hydrogen and then expose it and develop it, or you could cool it with dry ice. I chose to bake it in nitrogen, and it got some reasonable results, but wow, it was really, really hard. And none of this taking a pile of images, let the computer stack it up. And it got to be so hard that I realized I was spending all my time trying to get a picture and no time looking at the stars. So I actually stopped the film astrophotography in favor of the pen or the pencil and paper to sketch what I was seeing. And I got a binder full of sketches, and that was really, really satisfying, because when you start looking at something with the detail needed and for the length of time needed to sketch it, you see so much more. And so that was really, really good. And then along came CCD chips and computers, and it's now much easier to do astrophotography than it was with the old-fashioned stuff. Gosh, even the guiding of the telescope was you watched a star for half an hour, and you had a little joystick to manually move the mount when it drifted, and it inevitably drifted a little bit. Now it's all computer. So yeah, so the drawings were really useful, really taught me how to look, and it was enjoyable too.
Yeah. Okay, well, very good. Any other questions for Ian? Like, we're going on 5 after 9. We've been going for over 2 hours.
Such an
Okay,
amazing presentation. It was just amazing.
Good. Oh, thank you. Yeah, it's my pleasure to do it. I wish all of you the best of luck. I tried to think what worked for me and what should I have done differently back in 2017, and so I hope it's been helpful, and I'd like to see some of your results too.
So with respect to seeing the results, what I encourage people to do is to post their photos if they are lucky, or I guess if they're able to capture the clips, to post them on the meetup site for this presentation. Okay,
Good idea.
very good. Okay, well, thank you very much, Ian. I appreciate you taking the time, and it's very informative. And I wish you the best of luck in Texas. And I hope it's not cloudy down there and clear here.
Yeah, I'll be, if it looks like it's going to be cloudy, on the Sunday, I'll, instead of having a burger and a beer with my buddy in Dallas, I'll be driving north.
Yes, yes, chasing the sun.
Yeah, you bet.
Yeah.
Okay, good luck
Okay.
to both of you, and thanks for having me. It's
Okay.
Part of my pleasure is sharing the night sky and things astronomical.
All right, thank you very much,
Thank you so
Ian.
much.
Yeah,
Thank
thanks,
you.
Ian.
Fantastic. Thank you
Thank
so
you.
much.
Thank you.
Oh, and everyone, don't look at the sun
Right.
without the glasses.
Without a filter.
The future is
Okay,
so bright, we have to
I'm
wear
going to
shades.
sign off. I'll leave you to finish your
Yeah,
meeting.
Okay.
Talk to you again soon, Richard.
Okay, thanks, Ian.
Bye-bye.
Bye-bye. Okay, so I guess we'll end the meeting unless anyone wants to talk about anything. So I think I certainly will be, I think I'm going to buy a heftier tripod. The one I have is, I keep putting the telephoto lens on, and I notice the ball head on it. It just slowly drops. Yes. Next thing I know, that's the ground I'm taking a picture of. So, so I think I may just go to, I know some of these used stores, have tripods there, and get a big hefty one. One I'll never use again, probably, but anyway. Okay. So with that, I
Also,
think,
we should
yes.
just say hi to Rod. It's probably one of his first calls that he's joined. So welcome, Rod. Nice to see you.
Oh, okay. 1 second. I look here. Oh, Rod McPherson. He's on mute right now. Maybe I can unmute him. Ask to unmute. Okay. We won't put him on the spot. Oh, we're frozen. Or maybe it's Catherine's frozen. Oh, we're not frozen. Okay. So we welcome Rod to this meetup meeting, and we'll sign off now. Oh, I better stop the recording.
Thank you,
By the way-
Richard.
By the way, everyone failed. You forgot to remind me to start the recording.